Alright, this set of problems will calculate the number of periods required to meet the conditions stated in the problem. This first one, Fred wants $1 million in his retirement account when he retires in the future. His retirement account already has $200,000 in it, so he took $200,000 out of his pocket today, and he's going to add $500 every month, or I'm sorry, he's going to add $6,000 every month over the next umpteen years. That's what we have to solve for. And his account is earning 8% annual interest. Alright, so with annual compounding, the NPER open parens, the rate 8% per year, the payment negative $6,000, the present value negative $2,000, and he wants to have a positive $1 million in the account at the end. Note that the direction of the payments, the present value is money he put into the account, the payments are money he puts into the account. At least one of these three has to be of the different sign than the other two. So in this case, FV would have to be set in there as a positive number because both the PV and the payment are going to be the negatives. Alternatively, I could have made PV a positive and payment a positive and FV a negative. Whatever, at least one of these has to be of a different sign than the other two. Alright, and what that tells me is it'll take him about 17.7 years to amass the $1 million. Alright, if I convert this into monthly, it won't be 8% a year, it'll be 1/12 of that, and it won't be $600, it'd be $500. That would be 205 months. If I divide that by 12, you can see it'll take slightly less, about a half year less than it otherwise would. Alright, remember, whatever you solve, if this is monthly and this is monthly, you're going to solve for monthly number of periods. If this is annual and this is annual, you're going to solve for the yearly number of periods. Alright, Susie owes $5,000 on MasterCard. She's not going to put anything else on the card. Card has an annual percentage rate of 18%, requires monthly payments. Okay, well, if it's 18% per year with monthly payments, that's 1.5% per month. She's going to send MasterCard $100 a month, and she wants to pay off her debt completely, and her debt is currently $5,000. Okay, so the payment is going to be a different sign than the present value because she has $5,000 of their money. She's going to take $100 out of her pocket to pay that off. Alright, so if we solve for the number of periods at $100 a month, I'm just going to copy this down again with cell references. It'll take 93 months, and that would be roughly, divide that by 12, 7 3/4 years, a little under 8 years. If she sent them $200 a month, then it would cut that time by about 1/3. So if you double the payment, the time required is cut by 1/3, by 2/3 rather. So a pretty big drop in the number of periods simply by sending them extra money. Alright, going on to the next problem. Aunt Matilda recently retired. She amassed $3 million during her career and is going to live high on the hog the rest of her days. The account earns 5% annual interest. She wants to withdraw $25,000 a month from the account until the money runs out. Well, you know, if she's earning 5% per year, but taking money out every month, we have to take 5%, divide that by 12 to get the monthly interest rate. And she currently has $3 million in there. We're going to solve for how long the money will last till it goes to 0. if she's taking out $25,000 every month. Now, by the way, if you took the monthly interest rate times $3 million, means it's going to earn $12,500 that first month before she ever takes any money out. So it's earning interest, and she's taking it out faster than the interest is being earned, but it's still going to last 166.7 months, which divide by 12, that's about 14 years. All right, Renee owes $50,000 in student loans. They carry an annual interest rate of 12%. She's required to make monthly payments of $717.35 to pay them off over 10 years. It was 10 years, 12 payments a year, and the interest rate is 12% a year divided by 12. That's 1% per month. She owes $50,000, so she's got $50,000 of their money today, and it's going to pay it off. Okay, so that's her current structure. You were given all we could actually solve for the PMT at 1% a month for 120 months. The present value of $50,000, take it down to 0. That's where we got the $717.35. So that part's already solved for you. Renee decides to get a second job so she can send $1,000 a month to get the balance down to $30,000. All right. So right now, we want to know how long it'll take if the interest rate's still 1% per month, and she owes $50,000. If she sends them $1,000 up until the time when her dad can make a $30,000 balloon payment or a single payment at the end of the period, how long is that going to take? And solving for the number of periods, it's 33 months, a little less than 3 years.